Hello everyone, Quentin here with Eagle 3D Streaming. We have a great video for you today. In this video, we're going to show you how to play multiplayer over the internet and with pixel streaming. Let's jump right into it. In this series, we will cover how to run multiplayer locally, how to open ports for multiplayer, how to run multiplayer over the internet for Unreal Engine, and how to pixel stream a multiplayer project. A big thank you to my team here at Eagle, Arslan, Habiber, and Hassan. They helped me a lot to get ready for this developer series. It's going to be an awesome one. Let's get right into it. The first thing we're going to do is to show you how to set up and run multiplayer locally. The reason why we're going to start there is because it will help us in the way to setting multiplayer up so that we can connect users over the internet. I like to go step by step, and it helps with the debugging process, and it also helps get you comfortable with setting up multiplayer, and you're able to know what to look for when things are going right and wrong. Before we get into setting up multiplayer locally, a few key concepts to mention. In order to set up multiplayer, you're going to need two things: your Unreal Engine application, and you are going to need a dedicated server. Now, the dedicated server is the application that runs that helps orchestrate the connections between all of your users or all of your multiplayers. There is also another way to connect, and that is through a listening server, but we won't be covering that in this tutorial. I'm not a big fan of listening servers because it forces you to have one server that is serving as both the dedicated server and the UE app, and it's actually easier and more scalable, in my opinion, to separate them out. Now that we're comfortable with running a dedicated server and two instances of Unreal on a single machine, we are going to take it a step further so that we can now run multiplayer on multiple machines, meaning we'll have the Unreal Engine application running on separate machines, and then we'll have the dedicated server running on its own individual machine. In order for us to do this, we're going to need 3 total PCs. The first PC is going to be for the dedicated server, and the second 2 PCs are going to be the PCs where you will be playing your Unreal Engine application. These PCs could be any gaming PC with an NVIDIA GPU and drivers. With the dedicated server PC, it's a little different. Now, if you remember from the first tutorial when we ran it locally, there actually is not any graphics rendering when you run the dedicated server. So the dedicated server PC could be, you don't really need a graphics card for this dedicated server. It's actually, you really only need CPU and RAM in order to run the dedicated server. So you don't need a gaming PC to run this, which should be a sigh of relief. You can use a much lighter machine. In this example that I'm going to show you how we're going to play multiplayer over the internet, I'm going to set up my dedicated server in AWS, and there's reasons for that. Of all the clouds that Eagle has tested, we've found that AWS is the best for dedicated servers. We've tried on Azure and other clouds, and we always run into issues, but with AWS, it's the cleanest and most reliable. That means that I'm going to then take you step by step through the process of picking your dedicated server and setting it up, getting all the port stuff correct so that you can use your dedicated server in AWS for multiplayer pixel streaming over the internet. The first thing we need to do, if you're new to AWS, is we need to pick out our dedicated server. And if you remember, we don't really need a GPU for the dedicated server because it's not rendering graphics, it's just orchestrating between your instances of Unreal. That means that we can use a much lighter instance in AWS, and I like the T3 instances. I'll provide this URL in the description of the YouTube video. Once we're at this page, let's go down and look at our choices. We have a nano, micro, small, medium, large, X large, 2X large. Now, depending on how many users you have connected to your dedicated server, the CPU or compute is going to increase. Typically, what I like to do is to start with the T3 Large, which has 2 vCPU cores and 8 gigs of memory. This is a good starting point, and you can then test to see how many concurrent users you can have attached to your dedicated server. And if you need more, you can just keep bumping up and you will be able to add additional users. For this example, we're going to start with the T3 Large because it's a good starting point. Now that we have selected our instance, let's go ahead and start setting it up on AWS. The first thing you'll need to do is to sign into your AWS console. And if you're new to AWS, go ahead and create your account, and when you first sign in, you should see something similar to this. We will have to create the instance of our dedicated server, but before we do that, I do want to check and make sure we have the necessary quota in order to create the instance. The way AWS works with a lot of the clouds is you can't just create any virtual machine that you want, because they're trying to make sure that, I don't accidentally create 1 million dedicated servers. And so the way that this cloud and all clouds that I know of police this is by limiting your quota on how many virtual machines you can create. That means that we do need to just quickly check and make sure that we have the proper quota. I move my mouse over to the search bar and I type in quota. And then I go to service quotas. On this page, I'll go over to manage quotas and I'll type in EC2. And if you're wondering why EC2, this is the term that AWS uses for their virtual machines. So let's select Amazon EC2 and then click View Quotas. And you're going to see that there are tons of pages associated with this. In order to make this super easy, I will provide this shortcut, but we just need to type in running on demand standard, and then we'll be able to see our quota. Here I can see that our quota is 512. And if the next question could be, well, how much quota do I need? It will depend on how many vCPU cores you would like. If you're going to start with the T3 Large, which is what we're going to do, then you will need 2 vCPU cores. I check my quota list and I can see I clearly have more than 2 vCPU cores. I have 512, so I'm good. But if you wanted to create, I don't know, T3 2X Large and you wanted 10 of them, or I guess you would need, 100 of them to get over that limit, let's say 100, then you would have to make a capacity request, because it would be 8 times 100. So you would need 800 total vCPU cores, and I only have 512, which means that I would then need to make a request for this. And the reason why I am searching for this is because you can see that it includes the T instance. And if we go here and double check, we are indeed checking out the T type instances. So that's how AWS organizes their instance types, by letters. We're using a T instance. That's why we're checking our quota for the T instance. If you run into a situation where you do not have the proper quota, just click request increase, specify the quota request, and then follow the prompts through. Usually it's pretty easy to get quota for the T instance. The other thing that you need to keep in mind is you need to make sure that you're getting this quota in the proper region. Now, if you've played multiplayer games like me, one of the things that you always look for is the multiplayer server closest to you. And now it may start to make sense why that is because the closer the server to you, then the lower the latency will be. In AWS, like a lot of clouds, they have regions all over the world. Make sure that you request capacity in the proper region by clicking the drop down and selecting the region that you would like your dedicated server in, to make sure that you request quota in that region. Because if you request quota in the wrong region, then when you try to create a server in Frankfurt, but I have quota in Ohio, then I won't be able to create my instance. All that to say, make sure that when you're checking your quota and you're requesting quota, that you have the region that you would like for your multiplayer server to be in selected in this top right. Okay, now that we know that we have the right quota, it's time to go ahead and create our instance. We'll do that by starting at the home screen and then clicking on EC2. Once I've clicked on EC2, the next thing I will do is I will click Launch Instance. When I'm at this page, I can begin setting up my multiplayer server. The first thing I'm going to do is to give my multiplayer server a name. Next, I need to pick the machine image. Since we are going to run this on Windows, I will select Windows, and then I need to select my operating system. Typically, I go with 2022 base, but you could also do 2019 or 2016, but always make sure you pick base and not core base. I will select 2022 base, and then I need to pick my instance type. I click the drop down and type in T3, because if you recall, we are going to be using the T3.large instance. So I type T3 to get more specific results, and then I scroll down until I find the T3.large, and I left click to select it. The next thing I'm going to do is to create a key pair. The key pair is very important because this is how you're going to remote desktop into your multiplayer server. It's important after you create your key pair that you keep it in a safe place and do not lose it, because you only get one chance to create your key pair, and that's right here when you're creating your multiplayer server. Make sure you keep it in a safe place, because if it's lost, then you'll have to terminate your instance and create a new one because you won't be able to remote into it. You can use an existing key pair if you have one created, but let's create one from scratch so that you have all the details. I go hover over create new key pair and left click, and then I will give my key pair a name, my multiplayer server key pair. Once I've given it a name, I select RSA for the key pair type and .pim for the private key file format. Once I confirm I have my name, my pair type, and file format, then I click Create Key Pair. You'll notice that my key pair will be downloaded into the download section of my browser. Once you see that it's downloaded, then take that file and put it in a safe place to make sure that you have it, because we will definitely need this later for you to remote into your multiplayer server. Next, I go to network settings. In this instance, you could create an existing security group or you could create your network settings from an existing security group if you have it. However, similar to the key pair, let's create one from scratch so we go through the entire process. For now, I'm just going to select Create Security Group and then click Edit, and let's give the security group a name. So I'll call it my multiplayer server security group. And I'll also mirror that in the description. The porting is probably the most important part of this process, but I'm not going to do it right now. We'll do it after the security group is created, and you'll see why later. For now, you can keep these settings as default, and once we create our multiplayer server, we'll come back and finish out the networking information. Lastly, determine the storage you would like for your multiplayer server. I'm going to do 60 just to make sure I have enough room for my dedicated server, but you could do a lower number depending on how large your server is. It's important to keep in mind that AWS does charge for storage, so try to keep this value as low as possible. Next, once I'm happy with these settings, I will click Launch Instance. And my instance will launch, and I will receive a confirmation that it is successfully created. I can then click on my instance ID, and it will take me to my instance. I can see it has the name of my instance. The instance state is running, because whenever an instance first starts in AWS, it always starts in a running state, and we can see the status check. If for some reason you weren't able to get to this page, or if you're not sure how to get to this page, if you're new to AWS, the way you get there is first log in to your AWS so that you see this page, and then click on EC2, and then click on Instances, and you'll be able to see your multiplayer instance. There's two possible ways you can get tripped up here and you're not able to see your instance. The first is double check to make sure you're in the right region. Your instance will only show up when you have selected the proper region. If I, for example, go to Mumbai, then it won't show any instances because I don't have any instances in Mumbai. So I go back to Ohio and I'm able to see my instance. The second place that you can sometimes get tripped up is I'm going to right click on this instance and click Stop Instance and then Stop. And you can see now that the instance state is stopping. Now you'll also notice that I have this flag right here which is filtering for only running instances. If I remove that, and then let's go back to the home screen, click on EC2, and then click on Instances Running, you'll see that it looks like I actually don't have any instances running. But that's not true. It's actually just this flag is filtering for only running instances. So if you see this and you're certain that you have an instance there, then double check to see if this is active or not. Just left click it to delete it, and then select your instance, which is right here, and then right click on it and start it. And I'll go ahead and go back to the home screen and go back so that we can see just that instance. One last thing to note before we move on to porting is whenever this instance is running, you will be charged by AWS. If we look at their pricing, you can see it right here for on demand. For the T3 large, it's about 8 cents an hour, or 9 cents, maybe closer to 10 cents when you include the operating system and storage. Just keep that in mind when you are working with your multiplayer setup, that whenever this instance is running, you will be charged. Only have this running when you're actually using it for multiplayer gameplay, and then whenever you're finished, please be sure to turn it off. Okay, now that we've gone through the hangups, let's configure the porting, and this is one of the most important steps of this process so that we can use your multiplayer server for multiplayer. Let's start at this page where I can see my EC2 instance, and then let's navigate over here to this left column to Security Groups. I will left click on Security Groups, and then I will find the security group I created. You'll have to keep in mind and remember the name of your security group. That's why I always label everything my multiplayer server and then dash and then then the type after that so that I can keep everything organized. Click on the security group ID. I see the inbound and the outbound roles. What we're going to do here is to allow all TCP, UDP, and all traffic on both inbound and outbound. Now, of course, this is just for a demo, and you'll have to discuss with your IT team for the proper network config, but this is just to get you up and running as fast as possible. Let's do the inbound rules first. I select inbound rules, then I go to edit inbound rules, which takes me to a new screen where I can begin adding the configuration. The first thing that we're going to do is to allow all TCP traffic on anywhere-IPv4. I'm also going to delete RDP. If you're wondering why, well, we're now allowing all traffic on all ports, and I don't want this rule conflicting with the other rules I'm going to create, so let's go ahead and delete this RDP rule. After I have allowed all TCP on IPv4, let's add a rule. All UDP anywhere-IPv4. Let's add another rule. All TCP anywhere-IPv6. So you can see the difference now. These first two rules are all TCP and UDP on the IPv4 protocol, and now we're just doing the same thing for the v6 protocol. I have all TCP for the v6 protocol, so let's now do all UDP by clicking add rule, all UDP anywhere-IPv6, and let's add two more rules, all traffic anywhere-IPv4, and let's add one more rule, all traffic anywhere-IPv6. So you should have a total of 6 rules that allow all traffic on both TCP, UDP, and all traffic, and you have deleted your RDP rule that comes as a default when you create your security group. So you should just have 6 here. Once I've confirmed this, I'll click save. And the inbound rules are now complete. Let's now do the same for the outbound rules. I first click on outbound rules, and you can see that I already have all traffic enabled for IPv4. The other thing that I'm going to do is also allow all traffic for IPv6. I do that by clicking on edit outbound rules, then click on add rule, all traffic anywhere-IPv4, and I'm going to go ahead and change this to anywhere-IP. So this one's anywhere-IPv4, and this one is anywhere-IPv6. So now I've allowed all traffic on both v4 and v6. Once I've confirmed I have 2 rules and I'm allowing both on v4 and v6, I click save rules, and now you can see the final configuration. On outbound, it's all traffic for v4 and v6. On inbound, it's all traffic from TCP and UDP. The next thing that we need to do before we remote into our instance is to set up our Elastic IP. By default, Amazon does not assign a persistent static IP address to your EC2 instance. Therefore, we need to do this by using what AWS calls Elastic IPs. Through an Elastic IP, we will assign an IP address to your EC2 instance that will persist as long as you have the Elastic IP assigned to that EC2 instance. If this step is skipped, then you'll run into trouble because the IP address of the EC2 instance may actually change over time when you turn and turn off the PC. And if you recall, the way that we communicate with your dedicated server is the IP address. So we want to make sure that the address is always the same so that we can always connect to your dedicated server through the same IP address. It will make things much easier so you're not having to constantly check to see what the IP address is. and then using that IP to connect. To set up my Elastic IP, I go to Network and Security and click on Elastic IPs. Make sure that you're in the proper region where your EC2 instance is. Once I've confirmed my region, I will click on Allocate Elastic IPs, and then I will go to Amazon's pool of IPv4 addresses, which looks correct, and then this is fine and this is fine. I'll click Allocate. Now I have created my Elastic IP. Once I've created it, I receive a message that it has been created successfully, and I see the name of the Elastic IP address. Next I need to associate this Elastic IP address, and I could click this, but let's assume that, for example, you forget, or you come back to the screen, or you just simply don't have this green screen. Here's a way to do it to always make sure you can associate it. I first select the Elastic IP address that I would like to associate, and when I say associate, all I'm doing is I'm just going to pair it with my multiplayer server, which I sometimes call the EC2 instance because that's the name of the servers that Amazon calls. When I say associate, I'm just going to attach it so that that IP address is always connected to my multiplayer server. I select the IP address, I click Actions, and then I go to Associate Elastic IP address. I confirm I have the proper Elastic IP. Resource type, I'll select Instance, and then we will choose my multiplayer server instance. I will select that. For private IP address, I leave this blank, and for reassociation, I also leave this blank. So I have instance and then the name of the instance. These two are blank. Once I've confirmed this, I click Associate. Now I have associated my Elastic IP with my multiplayer server, and we can see the instance ID, which is the name of the EC2 instance for my multiplayer server right here. And if I click on it, then I can see that that instance ID is, of course, corresponds with my multiplayer server. And then I can also check over here, and I know that I have my Elastic IP associated. The next thing we need to do is now remote into, now that we have everything set up, let's remote into this multiplayer server and set it up for multiplayer. Since I did just associate Elastic IP, one thing that I like to do is to reboot the instance just to make sure everything's properly configured with it. I'm going to reboot it, and then once it begins, or once it is again running, then I will resume and we will remote into the instance. After I rebooted my instance, I went ahead and also stopped the instance to show another important point for those new to AWS. For all of your servers, you can either have them stopped, which means they're not running, or you can have them running by starting the instance. This is important for two reasons. The first reason is AWS will charge you whenever the instance is running. So please be sure to make sure you're only running the instance when you want it running. And another important thing is sometimes if it's in a stopped position and I go to EC2 and then I click on instances in the correct region, you may not see it and you may not think that you have your multiplayer server. Sometimes Amazon does this where it just shows instance state is running, so it's only going to show me my running instances. If I close this, then I will see my instance right here. I'm sharing this just because so it doesn't trip you up if you actually don't see your instance. Double check to make sure that you're in the right region and that you don't have that flag, which will filter by only running instances. Now that I have selected my appropriate multiplayer instance, let's go ahead and remote into it. The first thing I'll do is start the instance, and it'll take maybe about 1 minute to start up. When my instance is finally running, I can click the refresh button and I should see the 2 of 2 checks passed, which means that it's now time to remote in. I select the multiplayer server and I click connect. I go to RDP client, then download remote desktop file. This is going to download the remote desktop file for my multiplayer server. The next thing that I need is my password. And this is why I mentioned it's important to keep your key pair, because now this is where we'll use it to get our password. Click on password, get password, and then click on upload private key file. Select your .pim key, and this was the key pair that I mentioned to create when we were creating our instance, and hopefully you kept it in a safe place, because now this is how we'll create our password. Select that .pim file and click decrypt password. This will produce the password that you will use to remote into your instance. The last thing that we need is the username that we will use to remote in, and that for me is administrator. Now that I have all this information, I can now remote into my instance. I will go ahead and go to where the RDP file is that I downloaded. So when I click download remote desktop file, usually this goes to the downloads section of your browser. Find this RDP file and click it. And again, make sure that your EC2 instance is running. If it's not running, then it will say it'll fail to connect. Once I double click on the RDP file, I will see this screen, and then I will click connect, and then I will see this screen. I will copy the password and paste it right here, and then I click remember me, and again, make sure your instance is running, and then I click OK. I'll then see this screen. I usually check this box and then say yes. I double click on the dedicated server shortcut, and we now see that we have our black screen running, which gives us the log and confirms to us that the multiplayer server is running. We've made a lot of good progress, and we have all of our networking and port information set up. We now have our dedicated server running. The next step is to connect to this dedicated server over the internet. In order to demonstrate this, let's now connect 2 PCs running our Unreal Engine application to this dedicated server. If we take a brief glance at our setup, we first have the dedicated server, which is this PC right here, which we have set up, and we have our dedicated server running. Now, let's set up 2 PCs running the Unreal Engine application that will connect to that dedicated server over the internet, and when they do, the players will be able to see each other in the application. In order to demonstrate this, I've set up 2 additional virtual machines that I will be running the Unreal Engine application on. Now, these machines can be any machines that you want. This could be your gaming PC at home, and this could be your friend's machine. These could be machines running in the cloud. It doesn't matter. I set these up through remote desktop just because it's easier for me to move between these 3 screens for you guys. But just so it doesn't get confusing, these PCs can literally be any PCs in the world that have an internet connection and a graphics card. You can now connect to your dedicated server. Okay, so let's now go to the 2 PCs that we would like to run our Unreal Engine application on, and let's also download the same package onto those PCs. And obviously edit out this pause. I'm going to go to Internet Explorer and just simply download both PCs, and we'll pause right here once I've finished downloading and extracting my application onto these PCs. Now that I have downloaded and extracted my files onto the PCs, let's take a quick look inside what those files are. The first file is the dedicated server, which of course I will not be running because these are the PCs that I will be running the game on. The second file is of course all of the build files for the application that I would like to run. The first thing let's do is double click on the Unreal Engine application so that it begins, and I'm also going to do the same thing on my second PC. And if you're not fully familiar with remote desktop, I have remoted into these two PCs from the PC that I'm working with here at home so that I can demonstrate this in real time side by side. I now have two instances of the game connected. And if you've watched our first video on how to connect locally, the command to connect multiplayer is open and then the IP address. Now, when we connected locally, we use the 127.0.0.1 because that is the de facto standard for IP address for connecting locally. This is going to be different. Instead of using the IP address of our local host, we now, of course, are going to use the IP address of our dedicated server. If we go back quickly to our architecture, I now have these two PCs running, which are these two PCs right here. Now, what I need to do is connect these to our multiplayer server, which I have right here. And in order for me to do that, I must connect to the static IP address associated with that dedicated server. And if you recall, in order for us to do that, we should go into the AWS instance that is running my dedicated server, and I can see it running right here, and I need to get my public IP address. There's a few ways you can do this. The first way is you can simply just look up here and it will have it listed. Public IP address 3.128.98.118. You can also open a browser tab and type in what is my IP, and it will also provide you your public IP address. We need the public IP address and not the private IP address. We do not want the private IP address. We want the public IP address. Okay, once I have my public IP address determined, let's open up one of these instances. And if you remember the command, I'll first press tilde, and then I will type open. Oops, if I can spell, open, and then I will now type in the public IP address of my dedicated server, which is 3.128.98.118, and I'll press enter. Okay. Now I will go to my second instance running, and I will do the same thing. I'm going to move this window over here so that I can again see my IP address. I'm going to press tilde and then I'll type in open 3.128.98.118 and press enter. Now let's take a look and see what's going on. Well, I have both instances of my game running, but I do not see each other. So something is the matter. And this is why I also like to do this locally first, because you may have also noticed that our dedicated server is not registering any of the connections. And the only way you would know this is if you have done it locally, so you'll be able to tell when things are working and when things are not working. And that's why it's so important to do the step by step. So I know something is the issue. The reason that we're not able to connect lies in the dedicated server. So if you run into this issue where you're trying to connect your PCs to your dedicated server and you're not seeing the connection being made, this is probably the reason why. In order to resolve this, let's click the Windows button and type in firewall. Once the options come up, click on the firewall and network protection. And in order for this to work, because of how multiplayer is set up, I have to disable my firewall. This is the fastest way in order for this to work. Now, obviously, I think we all know, the consequences of disabling a firewall and the security risks it brings. I'm simply doing this to show you the fastest way to get multiplayer working, and then you can configure your network settings how you wish. So now that I have fully disabled my firewall, and again, please note the risks in doing this, let's now try to connect to the multiplayer server again. Let's go to my first instance, and let's bring up that IP address, and now let's try it. Oops. Okay, so I'm now in my instance, and I'll type open 3.128.98.118 and press enter. Now we see a little something different has happened. The client has successfully joined the game, which is awesome. So, good sign, things are looking good. Let's now try it on this one as well. Oof, I need to get better at remembering these IP addresses. I type tilde and then type open 3.128.98.118 and press enter. Now let's go ahead and go full screen on one of these and look at what we have. We now successfully have both players in the game connected via multiplayer over the internet. And just to confirm that that's not some rogue AI character, let's open up the other instance over here, and you can see me running around. And again, these servers are totally separate servers right here, also separated from the multiplayer server. So we definitely now have this configuration, which is 2 users connected. Once you get to this point, you can begin getting creative. You could then have 3 or 4 of your friends all connect at the same time, as long as your Amazon instance is running. So this should get you to the point to where you have a lot of creative control in terms of how you want to set this up. But for those who are curious and want to learn more, we're going to take it one step further. And that step is I'm now going to show you how to add pixel streaming to this, so that now you're pixel streaming with multiplayer over the internet. That will be the next video. Now that you have successfully connected 2 PCs running your application to the dedicated server for multiplayer, you're ready to take the next step and now pixel stream from these PCs to anyone over the internet, so that now you can have multiplayer through a browser. In order for us to take this next step, let's first see how we got here. The first thing we did was we ran the 2 instances locally, and we had a dedicated server. There were 2 total components. You had your Unreal Engine application and the dedicated server. The next thing we did was we separated these components, where we had your Unreal Engine application running in separate PCs, as well as a separate PC for the dedicated server. Now for us to take the next step, where we are going to pixel stream the output out from these PCs rather than playing it locally, we need to introduce 2 new components to our setup. The first component is a matchmaker. And if you've ever played games like Battlefield or Call of Duty, you know that the matchmaker is the thing responsible for routing requests when I would like to connect to an instance, to an available instance for playing. In the context of pixel streaming, the matchmaker serves whenever I connect to my setup, I will connect to it through a URL. I enter in the IP address of the matchmaker, and the matchmaker takes over from there. It will route the request to an available PC, and then that PC will begin streaming the output to the users. So the matchmaker serves as the component responsible for receiving requests to play the game and then routing them to an available streamer. The other thing that we need is a signaling server, and the signaling server is the component responsible for communicating between the matchmaker, the Unreal Engine application, and the user that would like to stream that application. Now that we've introduced the components, let's see how they all relate to each other. In this diagram, you can see all the components that are color-coded the same, how this setup works. Now, I know this is getting a little intense, and by the way, Eagle has a service that does all of this for you at a fraction of the price that can be done in the cloud, so just keep that in mind. But these are the components. Now, you'll notice we have a new PC that I have introduced. And the reason we need that PC is because we need a PC to run the matchmaker. You'll also notice there are some similarities. We still have the dedicated server, and we still have our Unreal Engine applications. But the things that we have now introduced are 1, the signaling server, and 2, the matchmaker. So let's go back and just double check to make sure we can fully understand this. Previously, we only had 2 components. And when I say components, these are actual applications that have to be running in order for multiplayer pixel streaming to work. When we first did multiplayer over the internet, we only had these 2 components. Now we've introduced 2 additional components which will allow us to stream the output to a user through the browser. We can see those components in this setup. Here's the matchmaker, which will run on its own PC, and here are the signaling servers, which will run on the same PC that has the Unreal Engine application. In order for this setup to work, you will need an additional PC for your matchmaker, and it will also have to have a static IP address. Whenever you're streaming, it's kind of a standard to have static IPs for everything, or it will be things can break. So just keep that in mind. Every single one of your PCs should have a static IP if you'd like this to be successful and consistent. Now that we have our setup and we've taken a look at the architecture, we can now begin the process of building it up and deploying it. Another thing to keep in mind is that we have a much more detailed video on how to set up your matchmaker and your signaling servers to connect over the internet. I'm going to go fairly quick over these concepts because we already have a great detailed video of it, but I will still do step by step just in case you'd like to follow this video. We will be going faster, but you will have the information. But just the concepts won't be as explained as much. Okay, now that we know our architecture, let's get to work. Here I have the 4 PCs running necessary for me to have multiplayer and pixel streaming as well. Let's take a quick look at the architecture. I have also these 4 PCs. My matchmaker PC, dedicated server PC, and then the 2 PCs that will be running my Unreal Engine application as well as the signaling server. I've organized them the same way for you. In other words, this top left one is my matchmaker, this top right one is my dedicated server, and these bottom 2 are my PCs that I will be running the Unreal Engine application on. Before we get started, one thing that you might want to include in your checklist is note down the static IP of every single one of your PCs. It will definitely be helpful later on. You'll also need to note down the ports that your HTTP, Matchmaker, Streamers, SFU are all listening on. And again, we have a very detailed video on this, so I'm going to not explain the concepts behind these, but just for your checklist, make sure that you have all this information listed that you're seeing right here before proceeding with your setup. We have 4 total PCs, and across those PCs we have 1, 2, 3, 4, 5, 6 applications that we need to run. So in order to do multiplayer pixel streaming, you can look at it as I need 4 total PCs, and on those PCs I will have a total of 1, 2, 3, 4, 5, 6 total applications running. And the way that I'm going to take you through this is I'm literally just going to start all 6 of these applications, and multiplayer pixel streaming will start working. Let's start with the Matchmaker. I'm going to go to my Matchmaker PC and I will maximize it so I can work easily. I'm going to go into my starting file, and again, this same starting file that I have used up until now is also going to be used for the Matchmaker. And that's why it's so nice just to have both your dedicated server and your Windows application, Unreal Engine application, in the same folder, because now I can use the same file everywhere. The other thing that you'll need to have done to your Unreal Engine application is to have pixel streaming enabled, the pixel streaming plugin. We also have a video on how to enable the pixel streaming plugin, but when you do your build, make sure that the pixel streaming plugin is enabled or this setup will not work. Okay, let's go ahead and set up the Matchmaker. I go to my Unreal Engine application, then I go to the name of my project, samples, pixel streaming, web servers, get PS servers, and I double click on that, which will load all of my servers. And you'll see I now have my Matchmaker and I have my signaling server. If we go and we look at our architecture again, you can see that we're focusing on our Matchmaker right now. So let's set up the Matchmaker. I double click on Matchmaker, Platform Scripts, CMD, Run. After I double click Run, you'll see that the Matchmaker is being set up, and I simply wait for it to be completed. I'll allow if it asks. And we now have the Matchmaker set up. The Matchmaker is actually pretty easy to set up. This is all you have to do. And you'll now see that it's running when you see the messages HTTP listening on 90 and Matchmaker listening on port 9999. Okay, that's it for the Matchmaker. The next thing, and again, so now you'll see that I have this application, 1 out of our 6 applications running. The 6 being the Matchmaker, dedicated server, signaling server, UE app, second signaling server, second UE app. I now have 1 of the 6 running, so we're making progress. Next, I'm going to go to my dedicated server. So here is my dedicated server. Because I've got these organized, these 4 PCs are literally these 4 that we see in the architecture. Let's go to my dedicated server and let's start the dedicated server. I'm now in my dedicated server PC, and I'm going to the exact same file because I'm using these 2 files for my entire setup. So important to prepare this beforehand. I'll double click on Windows Server, and I will double click on my shortcut for my dedicated server, and now we have this up and running. So far so good and pretty easy. If we go back to our architecture, we now have 2 of the 6 Unreal Engine 2 of the 6 applications running. Our Matchmaker and dedicated server are now running. Making progress. Let's go now to our first PC and let's start our signaling server and Unreal Engine application. As you know by now, this bottom left corresponds to my first PC that I am going to use for streaming. So I will select it and I will maximize it so it's easier to work, and then I will double click on my starting folder, and then I will open up my Unreal Engine application. Now, as I've mentioned, there are two total applications that I need to run: the signaling server and the Unreal Engine application. I'm going to run these through BAT files. And again, I explain this BAT file setup, the reasons behind it, why we are adding certain information into the BAT files in our setting up multi-user pixel streaming. So please have a look at that video if any of this is confusing. But since we're moving through the steps fairly quick, just know that we have two applications that we need to run. And I'm going to run these through BAT files because it's the easiest and most efficient way to do this. So let's now set up our BAT files for both the signaling server and the Unreal Engine application. To save time, I've already created them right here, but we'll do this. We'll go ahead, and if you're not familiar with how to create a BAT file, let's right click and let's right click and say new text document, and then let's create the BAT file for the signaling server. And again, what I am doing is I am now creating a BAT file that is going to run my signaling server, which I have done right here. I'm going to right click on it and say edit with Notepad, and I'll clear all this out so that it's nice, neat, and clean. Now you can see that there's nothing here. I have, however, created my BAT file beforehand, so this is easier, so I'm going to also load that. And so now you can see what I've done. What I've done is I'm basically running the start signaling server PowerShell script, which will start my signaling server. And so I've created a BAT file that will run this specific application, this PowerShell application, and then I've added some arguments necessary for pixel streaming. I'm not going to explain these in this video because we have it in our multi-user pixel streaming video. So all I'm going to do is copy all this information and paste it into my BAT file that I have at the root of this folder. And that's important that you place this BAT at the root of this folder because I'm using a relative folder location to start this application. Now, of course, this setup will be a little different. The name of your Unreal Engine project will change. Since my name is DS Test 2, that's the reason why I've put that there. But yours is going to be different. I'll provide this this BAT file command in the description, but just know that you'll have to update this for your actual project. Now that I've added that information in, let's go ahead and save it, and then let's also create our BAT file for our Unreal Engine executable. Going back to the architecture, we've now created our BAT file that will start our signaling server. We also are going to create a BAT file to start our Unreal Engine application. And I'm just using BAT files because it's easier when you're setting this up for pixel streaming. There's multiple ways to do it. I prefer the BAT file. Okay, this one's done. Let's create our second BAT file. I have also created this beforehand, but I will create it from scratch, and I'll just call this start UE app.bat. Okay, and then I'll right click on it and edit with Notepad++. Oh, and I use Notepad++. There's lots of different editors you can use. I'm just using this one because it's simple and free. Okay, so let's take a look at the BAT file that I made in advance. this one's fairly straightforward. The first part is the name of your Unreal Engine executable that you want to run, in this case ds-test2, and then I have some arguments that I include which are necessary for pixel streaming. I'm going to copy all of this and paste it into my new bat file and click save. And I will close all of this. Okay, so now you have your two bat files necessary to run the two applications needed for multiplayer pixel streaming. Before we run those, if you notice what we did for the match on the matchmaker, we have to first set up pixel streaming. So I'm going to go to the name of my project, samples, pixel streaming, web servers, get psservers.bat. I'll select run anyway and wait for the installation to complete. The next thing that I'm going to do before I run my bat files is I need to make one modification to the config.json file. I will right click on the config.json file and you will see that I have a list of arguments. The argument that I need to modify is the matchmaker address. Well, what do I put here? If we go back to our architecture, I have listed the IP address, I have listed the name of my matchmaker IP address right here. So I actually know what the IP address is beforehand, which makes the step easy. I just simply go over here and I will type in that address in this field, 176.97.35. Okay, now that I have my matchmaker IP address added right here, I will go ahead and maximize this. Then I'll right click and save and close. All right, now that we have set up our pixel streaming files by going to ds-test samples, pixel streaming, web servers, get psservers, I ran that. I also went to signaling web server and modified my config.json file to have my matchmaker address, and I've also created my two bat files. Now I'm ready to actually start running things. Okay, so we have the bat file for the signaling server and the Unreal Engine application. Let's now start both of those programs using these bat files that we created. I'll double click on start signaling server.bat to start the signaling server. I allow if it asks, and then I close. And we can see that not only has the signaling server connected, it has also connected to the matchmaker, which is awesome. If we go to this diagram, we see that we have our matchmaker, and if we go to this PC, we'll notice that we have now added a connection to the matchmaker, which is great. Now, we had the signaling server running. The last thing that we need to do is have our Unreal Engine application running. I go back into my first streaming PC and I'll maximize it. And now I will start my second bat file to start my Unreal Engine application. Now, because I'm doing it as a bat file, you'll see a command window that looks similar to this, and it won't be readily obvious that your UE application is running. The way that I like to check and confirm that it is I just start my matchmaker and confirm that my Unreal Engine application is running. Okay, now I have my Unreal Engine application and my signaling server running. So let's check in on the architecture. I have my matchmaker already running, as well as my dedicated server. Now I have also started the signaling server and the Unreal Engine application on my first streaming PC. That means that I now have a total of 4 of the 6 necessary applications running. The last thing for me to do is to set up my signaling server and Unreal Engine application on my second streaming PC. In order for me to do that, I have my second streaming PC here in the bottom right, and now I'm going to start the signaling server and Unreal Engine application. I select my second streaming PC and maximize it for it to be easier to work, and I go into my root folder of my Unreal Engine application. The first thing that I need to do is to set up my bat files. And since I've already shown you how to do this using the first PC, and for setting up my second one, I'm just going to simply move them into place so that we have them in position. The next thing that I need to do is also start or install and set up all of the Pixel streaming servers. So I go into Windows, the name of my project, Samples, Pixel Streaming, Web Servers, and then I double click on Get PS Servers, and I will click Run Anyway. Once that's finished setting up, I will then go into Signaling Web Server, and I will go to my config.json file, and I have to do the same thing, which was specify my matchmaker IP address. I'm going to minimize this so I can look and see what it is, and I see that it's 198.176.9735. So I go down to matchmaker address and I type in 198.176.97.35. I right click on my config.json and I save it, and then I close everything so that it's nice, neat, and organized. Okay, let's go back to your application and let's first start the signaling server. And we'll wait for it to install and start running. I'll allow if I'm prompted. And now we see that not only has the signaling server connected, but it's also connected to our matchmaker. Going back to our architecture, our matchmaker is in the top left, so I'm going to maximize this just to show you. Here's the first connection, and now we have the second connection. I will minimize this and briefly go over what we've done. We now have the matchmaker running. We have our dedicated server for multiplayer running. And we now have the signaling server and Unreal Engine application running on both streaming PCs. So we have now all 6 applications running. Oh, shoot, I forgot. Okay, let me start my Unreal Engine application as well. Sorry guys, I forgot to do that. Okay, now I have all of my 6 applications running, and I will go into Task Manager just to confirm. There it is. Okay, now we've got all 6 running. Now that I've confirmed that I have all 6 of these applications running, the last thing for us to do is to pixel stream multiplayer over the internet. The way that I do that is I want to connect to my matchmaker, because my matchmaker is going to be the one responsible for setting up the streaming. I'll connect to my matchmaker, which will then route me to an available streaming instance. And once I'm connected to that, the signaling server will then be the middleman in terms of streaming my Unreal Engine application to me. So how do I connect to my matchmaker? It's actually really easy. I just specify the IP address into my browser tab, and I also specify the port because this is the port that the matchmaker is listening on. Here I have a standard Google browser tab, and this is now on my local PC. When I say local PC, all of these PCs in my setup are in the cloud. So none of these are running locally on my desktop. These are all cloud PCs, somewhere in the United States. Now I am bringing up my browser tab that is running locally on my computer, and I'm going to use this to demonstrate pixel streaming multiplayer over the internet. So the way I'm going to do that is I'm going to simply enter in the name, the IP address of the matchmaker, and specify the port. So I'll do that by typing in 198.176.97.35:90, and I'll press enter. And I will click to start, and we see that I have my first instance of Unreal running. And you'll also notice that the IP address has changed because now it's connected to who? Well, I can go here and see it's connected to this PC. All right, making progress. Let's open a second tab now. And this time I'm going to enter in again the matchmaker address. And when I say the matchmaker address, that is the IP associated with my matchmaker. So I'm going to enter that in, and that is 198.176.97.35:90, and I'll press enter. When that happens, you'll notice that again my IP address has changed because now it is connected to the other streaming PC that I have a signaling server and Unreal Engine application running. If I then look at these side by side, you can see I now have my two instances of my pixel streaming running. You'll also notice they're not connected multiplayer. The last thing we need to do is now to connect these to our dedicated server. If we look at our architecture, we have our dedicated server here along with the IP address associated with it. We'll use the same approach that we used in our previous video of how we connected locally in order to connect to our dedicated server. So I will type in open and then the IP address of my dedicated server. Let's go to our first streamer that is streaming our first browser tab that is streaming from this, that is streaming to and from this PC. Let's go to our streamer. Let's go to our first browser tab that is connected to this streamer, and we will type the tilde key, and then we will type in open, and then the IP address of our dedicated server. Open 3.128.98.118, and I'll press enter. Once I press enter, let's quickly check out what's going on our multiplayer server. You'll notice that a join has succeeded from my pixel streaming streamer, which is excellent. Okay, so we now have the first browser tab connected to multiplayer. The last thing that we need to do, of course, is to connect our second streamer to the dedicated server because they currently cannot see each other since they're not both yet connected. In order to connect my second streamer, I'll do the exact same thing. I go and I check my dedicated server IP address. Then in the second streamer, I go here, I press tilde, and then I'll type in open 3.138.98.118, and I'll press enter. And we now see that we have successfully set it up. Now you have both players connected to each other while pixel streaming. Now, if you want a much simpler and straightforward and easy way to do this, Eagle 3D Streaming has all of this set up and automated for you. All you literally have to do is upload your dedicated server. So you'll zip it up for Windows, upload it to our platform, and then once it's uploaded, you can start your dedicated server and you will immediately have multiplayer running. So I have my 2 instances starting up, and we have everything set up on the back end so that these 2 will immediately connect and via multiplayer. Another thing to mention is we have a free open source template which I am sharing with you right now on the screen so that you can automate multiplayer setup within the engine, within your Unreal Engine project as well. So this is going to, now that the concepts of multiplayer are understood, this is going to rocket ship your development. We do have a 7-day trial if you're interested in trying us out. This is Quentin Anderson with Eagle 3D Streaming. I hope you've enjoyed this tutorial on how to set up multiplayer with Pixel Streaming, and we will see you in the next developer series. Thank you.
Upload your first Unreal Engine project on our Pixel Streaming platform for free. To create an account, go to account.eagle3dstreaming.com/sign up and get a free 7 days trial. Eagle 3D Streaming, it's just easier.